In this lesson, Lyndon will show you how to clean data using R. And I say data cleaning, but it's more identifying where the data goes wrong. Because if you can identify where the data goes wrong, you know where to fix it in your source systems, and the next time you do a data dump into your data warehouse, the data will be fixed. Lyndon and I have decided to include this tutorial for two reasons. First of all, either you or your data analyst is working or will be working with R in the near future. So it's important that you have some understanding of how R works, what it looks like, what it feels like, etc. On the other hand, we want to show you the process of data cleaning, and we can tell you all about it in a video, but what's more fun than just seeing it happen in front of your eyes and seeing how Lyndon gets some descriptive statistics on the data that help him identify whether the data is wrong and how he can play with the data and make sure to fix the data before he does the analysis. In this tutorial, Lyndon will be using RStudio. In addition, he uses an absenteeism dataset. And you can find a link to this dataset in this week's course material, so you can do the analysis yourself in RStudio, which is free to download and freely accessible to everyone. I'm sure you'll like this lesson. Good luck and have fun watching.
We're going to use RStudio as our interface to do some stuff in R, so I'm going to boot it up. Okay, let's create a new script here. I'm going to take our absenteeism data file that I have here and read this in, and we'll use it as our example. What you see here is a command that essentially says there's a CSV file out here called mfgemployees4, and I want to read that in, and it is a CSV file, and I want to assign that to the name mfgemployees. So we'll select that, we'll run that, and you notice down below that it has run that down, and that's essentially what that means. Okay, the next thing we want to do is see what this data file consists of. mfg employees. And I use what we call an str, or a structure command, because I want to see what's in this file in terms of what makes it up. And so once again, I select that, I run that. And now when you look down below, you'll see the various pieces of information that make it up. You can ignore the stuff up on top. We have an employee number, a surname, given name, gender, city, job title, department name, store location, division, age, length of service, absent hours, and business unit. Now, one of the things that I want to draw your attention to is any one of them here that says factor is essentially categorical data. It's recognized, R is recognized it as categorical data. And when you think about, most of these are textual pieces of information, so that makes sense. In addition to that, you find that we have age, length, and service as being all numeric. And then we also have one more item here, which is a categorical variable called business unit. And you want to have an understanding of what's textual or categorical and what's numeric, because what you do to cleanse your data or to find data that needs to be cleansed depends on whether you're dealing with categorical information or numeric information. And one of the misunderstandings or notions that I want to dispel with respect to cleansing in people analytics is that most people somehow think you should be cleaning. It means cleaning your data in the data set that you have in something like R, and then going from there. The problem is if you have a data set from somewhere else and you try and clean it up in R, the next time you bring that data in a month from now with updated information, that data is going to be still unclean, in the sense that whatever was a problem last month is going to still be a problem this month, and you're going to go through the process of cleaning up your data again and again and again. So the issue here with data cleansing as part of the people analytics, one of the people analytics steps, is that you are looking to identify data that needs to be cleansed, but not necessarily cleanse it here. I will give an example of cleansing it right in R so you get an understanding of what's going on. But the general rule is if you got data that doesn't look right and needs to be corrected, you change it in the source systems and you bring your data back down to your tool such as R that you're using here. So on that basis, one of the things that you can do, for instance, on the numeric data is get immediately an idea of what the distribution of the data is on that. So what I'm going to do is I'm going to issue the following command, summary, and what this is saying, take the age variable down here in this MFG employees file and summarize that for me. Now what summary does is it gives you the statistical information on what you have in that data in terms of minimal number, the first quartile, the median, the mean, third quartile, and the maximum. Now when you look at that, if this is real organizational data, you look at this right away and say, this can't be. We can't have a person that's 3.5 years old in the organization. And if you're in a jurisdiction where you have mandatory retirement age at 65, you couldn't have something like this either. It tells you right away that you got values there that are not appropriate. One of the other ways in which you can identify that is to issue the following command, which is hist for histogram, and create a histogram of this information to see a visual. And you notice here that, yep, you got what is likely to be around 18 here, and you got numbers below that, and 65 is probably about here, and you've got people that are above that. And so you want to clean those up in the original data. You want to find out if indeed those values can't be, what was wrong in the original data that has to be corrected so you don't get those in your data. But let's suppose, just for the example here, that we decide to clean that data in R, knowing that we're going to have to deal with it anyways the next time we bring it down. Oops. If that's the case, then what you can do is something like the following. You can say, okay, I want to take this MFG employees data set and I want to subset it. I want to take only those employees that are greater than equal to 18. So I run that, and you look down below and that's actually run. Then correspondingly, you want to say to yourself, you want to say to yourself, take that data set that we have just created and subset it again and give me everybody that's only 65 and under. So once again, you look down here and that's been run. If you were to now run these commands again, there was summary command. And I'll just select that. You'll notice now the minimum is over 18 and the maximum is at 65. And if you want to prove that, what you do is you can create the histogram again. And you notice now that you have a proper distribution here in terms of the values. So that's an example of taking something that's numeric and looking for some obvious things. In the case of age, if you have those things that legally people are required to be 18 or over, that would be a general rule that would apply. And if you have mandatory retirement, this would apply. So that's the example. I'll come back to another numeric example later, but what I want to do now is take an example of a categorical piece of information. And what we can do in terms of categorical information is do a table of counts by whatever categorical piece of information that we're looking at. And in this case, I want to look at division. I want each division in the company and account for each division. So I run that. And indeed, if I just select counts here and run, it shows me what those divisions and their counts are. It gives me an idea of what the division names are. Now, the reason why that's important is that if you could look at and see something in here that is gobbledygook, it's just not a value, then once again, you know that something needs to be cleansed in the data. This kind of format isn't all that useful when you have larger amounts of lists or data that are there. And sometimes what you have to do to put this, instead of being the horizontal format, in the vertical format, you say, I want this as a data frame, and then all of a sudden it puts it in the vertical format. And the idea here is you have data essentially in alphabetic order, so you can go down the list and look for anything that has a value that just doesn't make sense in terms of something that you're looking at. If you had a division X down here and that wasn't a valid name, that would stand out right away. Another way you can take a look at what you've got with respect to categorical data is do a bar plot. So we'll run that. And this is a horizontal bar plot that shows you the counts by the various divisions that we have. You'll notice here that sometimes this isn't all this useful because you have to put in some extra commands to make these labels horizontal, and so you might have to make some changes to get that. Correspondingly, sometimes you've got, this is just 6 or 7 categories. Sometimes you may have categories that are much larger than that. And so what we can have, for instance, is something like the city information, and we do the same thing here. And we run that. And the bar plot there, it shows, over 100 different bars, and it only shows a handful of the names there. So that isn't all that helpful. And if we do just the counts here, you'll get, again, this horizontal and then vertical list, which isn't particularly easy to look at. So typically, what you want to do again is as data frame trick to make the information visible in a way that's a bit easy to look at in terms of scrolling. And here we have that. And here again, in terms of city, you'd look for any name that just comes up as gobbledygook and just doesn't come up as a valid value. It's that kind of thing you do with categorical data. And in categorical data, one of two things happens. Either you have lists from your source information system that are valid lookup tables that have all of what the valid values are, or if you don't have it that way, what you do is you have a content subject matter expert look at the list that you've created here and have them go through and validate whether there's anything in there that isn't a valid value. And those are the ways in which you look at your data for purposes of cleansing. And once again, I have to reiterate, we use an example where we cleanse the data in terms of getting rid of people that were over 65 or under 18 in the R data set. But normally you wouldn't do that. You go back to the source system to change that information. And in changing it there, then you don't have to keep redoing it. The purpose of data cleansing using tools like R and these charts, these tables, and so on, is for data cleansing identification. It's for identifying things that don't look right. It gives you the clues as to what needs to be changed in the source system. One other numeric thing that I'm going to look at is something called absenteeism rate. We're going to calculate that here right now. This line basically says absenteeism rate is the absenteeism hours, and what I'm doing is dividing by 2080, which is 52 weeks a year, 40 hours a week, and then multiplying it by 100 to get percent. So I'm going to run that, and that gives us an absenteeism rate. And if we want to see that, I could say structure MFG employees again, and when we run that, we now see that we have an absence rate down here. Now, something like an absenteeism rate, there must be a typical average, even in an industry average, for what maybe a healthy rate of absenteeism is. But at the start, you have no idea compared to something like age, where there may be legislative requirements that say you can't have people more than or younger than 18 working, you can't have people over 65. If those are legislative things, you know what to look for those things. In some numeric things, absenteeism rate may be one of those things. You don't necessarily know if something is an invalid value or not. At least on the face of it, you don't necessarily know that. You usually have to track those things down if they look odd, and determine whether there's something wrong with the data or whether it's really representing something that exists. And one of the ways in which you can do that is to create what we call a box plot for that information. And I'm bringing up a library in R called ggplot, and I'm creating a box plot of the absenteeism rate to have it to take a look at it. So I'm going to select that, and then I'm going to click Run. Now, when we do that, you'll notice over here that the information that is shown here is a box plot of absenteeism rate. This black line is the mean absenteeism rate. The other two here are the upper quartile and the lower quartile of data. Now, one of the things that is the case here too is you've got a bunch of dots way out here on this chart, and you notice that those are 10% above. It looks like the typical average absenteeism rate is only about 2.7 or something like that. But you've got people out here that are 10% or more in terms of an absenteeism rate. And the thing is, you don't know whether that's bad data or whether this is real data, but these are things where indeed these employees are an issue for the organization in terms of their absenteeism rate, because it's at a much higher level. And so to determine this, you have to go back to the original data, find out exactly the detailed information that makes up this 10%, and find out whether from the original data you need to recheck whether that was legitimate or not. If it is, there's nothing that you have to do. But for purposes of looking at your data, this is basically telling you that while a huge amount of people fall within the bounds that you would expect, there are some significant outliers here at 10% or above that the organization is probably going to look at and want to look at. So that's just a brief primer on data cleansing within people analytics and using R to do that. And so I hope this helps you get an idea of the things that you can use R for and what you need to do for data cleansing. And again, the most important thing to understand is you use something like R to identify data that needs to be cleansed, but you clean that data in the original system and then you bring it back out for further study. That's the whole point about data cleansing within the people analytics process. Thank you.